Hello, welcome to Cerebral Lectures, and today we will discuss glycolysis, and not just glycolysis, the regulation of glycolysis. So stay with me. Here is a mind map for all of the stuff I will cover today in these videos, because I will be uploading like 2 or 3 parts. First, glycolysis, obviously. Second, we will discuss the reactions, the regulated steps, and the hormonal control of glycolysis. Let's start first with the reactions. Here is a very pretty composition of all of the reactions that compose the glycolysis pathway. But before that, let me explain to you what actually is glycolysis. Like, the definition of glycolysis is the metabolic pathway by which glucose is converted into pyruvate along with the production of high energy molecules like ATP and reduced NAD. This is the definition of glycolysis. It is the pathway to produce energy in our body. First step is about glucose, the conversion of glucose into glucose 6-phosphate in the presence of hexokinase enzyme, and ATP is being utilized here. Because for the conversion of glucose into glucose 6-phosphate, we need a phosphate group, and ATP is the donor for phosphate. Glucose 6-phosphate is then converted into fructose 6-phosphate in the presence of phosphoglucoisomerase enzyme. Fructose 6-phosphate is then converted into fructose 1,6-bisphosphate, a reaction similar to this one. ATP is the phosphate donor here, and phosphofructokinase is the enzyme. Now, each fructose 1,6-bisphosphate then produces a molecule of glyceraldehyde 3-phosphate and a molecule of dihydroacetone phosphate. But the reactions can continue only with glyceraldehyde 3-phosphate. So what should we do with the DAP? Obviously, isomerase enzyme will convert this DAP into glyceraldehyde 3-phosphate, and then triose phosphate dehydrogenase enzyme will act on glyceraldehyde 3-phosphate to convert it into 1,3-bisphosphoglycerate. Now, a simple concept here is that each molecule of glucose goes into 2 molecules of glyceraldehyde 3-phosphate. Now, reactions will continue with each of these glyceraldehyde 3-phosphates. So each conversion of glyceraldehyde 3-phosphate into 1,3-bisphosphoglycerate needs a molecule of NAD positive. So if 2 reactions are going, we will need 2 NAD. So this is an addition. Obviously, we will not write the reactions on each glyceraldehyde 3-phosphate separately. We will just sum them up like this one here. So now 1,3-bisphosphoglycerate is converted into 3-phosphoglycerate in the presence of phosphoglycerokinase enzyme. But this is the substrate level phosphorylation. Here, 2 molecules of ADP are being converted into 2 molecules of ATP, which means that these are the energy producing steps. First one is this and second one is this. 3-phosphoglycerate is then converted into 2-phosphoglycerate by this enzyme phosphoglyceromutase. 2-phosphoglycerate is then converted into phosphoenol pyruvate by enolase enzyme, and the final step is the conversion of phosphoenol pyruvate into pyruvate by pyruvate kinase enzyme, and again a substrate level phosphorylation where 2 molecules of ADP will be converted into 2 molecules of ATP. So, if we look at the energy usage and the energy output, the first step and the step here, these are the energy consuming steps, whereas this step and this step, this and this, these are the energy producing steps, which means if we look at the energy producing steps, 2 molecules of ATP, 2 molecules of ATP, 4 ATP total. But no, 2 molecules of ATP are used earlier. So 4 minus 2, we will have 2 ATP. This is the net ATP. Very simple. I hope I have conveyed the concept properly. Here I would like to explain what is substrate level phosphorylation. If we just look into the definition, it says that the usage of energy from a substrate of a pathway to form a high energy molecule like ATP or GTP. But what is it actually here? 1,3-bisphosphoglycerate will give off a phosphate group to ADP to form ATP, and 1,3-bisphosphoglycerate will then get converted into 3-phosphoglycerate. First it had 2 phosphates, but now it has 1 phosphate because it donated one of its phosphates to ADP to form ATP. This is how substrate level phosphorylation works. And same is the case here, where phosphoenol pyruvate, which had its phosphate group, donated its phosphate group to ADP to form ATP. We know that 2 sets of reactions are being carried out. So one reaction will form ATP, other reaction will form ATP, and the total ATP 2 ATP. That's why we have a summation here, 2 ATP, 2 ADP. I made it pretty much clear. I hope you understood it very well. For regulation, let's jump to the part 2.